Okay, so the next one, E, says draw a scatter plot of PD as a function of blood pressure. So who can tell me here which one is going to be the independent variable and which one's going to be the dependent? Lyndon.
Age is independent.
Which one?
The age is independent.
There's no age here. It's blood pressure reading versus the blood pressure.
Oh, blood pressure is independent.
Yeah, so this is their blood pressure reading, and then this is their actual blood pressure. There's a bit of a difference, right? So PD, when doctors measure blood pressure, they compare blood pressure to the average blood pressure. This comparison, so PD is actually a comparison of blood pressure. So which one did you say, sorry, Lyndon, is the independent?
The blood pressure is independent, while PD is dependent.
Very good, yeah. So this is dependent, and this is independent. Okay, and you might know that just from X values are usually given and Y values are calculated. Okay, that's another way to think of independent versus dependent. But what that tells us then is if we know independent and dependent, we know the independent variable is going to be on the x-axis and the dependent variable is going to be on the y-axis. Okay, and then we just do a scatter plot. So you take these values and plot them. Okay, that'll give us this scatter plot here. Okay, so these values are taken directly from this table. So 95, 39, you'd go to 95, 39. Okay, any questions on how this scatter plot was created? Gennaro, question? No? Okay. All right, moving on. So we've created a scatter plot now that looks like that. Okay. F, next one, says describe these characteristics of your graph. Domain, range, zeros, existence of any asymptotes. Okay, so let's do that for this. Domain. What's the domain of this particular function? Anybody? Domain. Yeah, Ramon.
X must be greater than 0, but less than 160.
Okay, so X is greater than 0, but X is less than 160. Okay, so you're trying to make a domain with kind of a function or an XER type graph. It's not quite the case here, okay, because it's a scatter plot. All right. Yeah.
It'd be x equals 95, 100, 105, 110, 115, 120, 125, 130, 135.
Right, so all of the values in the table, right? So all of these values, okay? This would be the domain. Okay? Yep.
Do you have to put x equals? Because by stating domain before
Yeah,
the thing is...
you're right. You could just write it like that. Yeah, it doesn't matter. Okay, so that's all we know. The book here has said that the domain is PER, where P is greater than and equal to 0. So they're making the assumption that there's values in between here. If all the information we had, though, was this graph, you would have to write the domain out like this. Okay, so they're making that assumption that we're connecting these dots and that these go up and off. Okay, so they're saying that the X values or the P values, which are here, is just have to be greater than 0. So positive, because you can't have a negative blood pressure. Okay, I'm saying that this is more accurate because this is all the information we've given for this graph. Okay, so we've created a scatter plot. This is the true domain. That's all we know. Okay, we don't know that necessarily that someone is going to have a blood pressure within this range at that distance from the standard. All right, so the range, now are the y values. You would just put in the y coordinates. Okay, so we would go back to here. They would be 39. just all of the y values from this table, okay? I don't have them on me, but that's what the range would be. Okay, next is the zeros. So what are the zeros in this case? The only zero we know is the actual right on average, okay? If you have the same blood pressure as the average, which is 134, your blood pressure or your dependent value would be your value minus the average, which is if you had 134 minus 134, then you would get a value of 0. So right here at 134, just below, before 135, there's a 0. Okay? Remember, 0 are the value of x when y is equal to 0. Okay, that's what a 0 is. Okay, it's the x value when y is equal to 0. So our zeros would be x equals 134. Or in this case, p. Any questions there about zeros? All right, next one asks for asymptotes. There's no asymptotes. Okay, and the last two, I'm going to just reveal the answers here. So the shape of the graph, we're going to describe the shape of the graph. The shape is a V. All right, that's easy enough. And it's increasing for P greater than 134. So if we're greater than 134, we're going up. And it's decreasing for P less than and equal to 134. We're going down. Always reading the graph from left to right. Okay, for increasing versus decreasing. And finally, it says the behavior of the values of the function PD as P becomes larger and smaller. This is kind of the same idea, right?
Perfect, sir. So would Luigi Rail return back to student services? Luigi Rail return back to student services?
As P goes to infinity, PD goes to infinity. So as P, which is our independent, goes to infinity, PD, which is our dependent value, is also going to go up to infinity. Okay? As P goes to negative infinity this way, our PD is going to go up to negative infinity, or into positive infinity. Okay, any questions about this nomenclature? Anyone confused by that?
Can you repeat that?
Sure. So as P, so the independent value, which is the x-axis, goes to infinity, so goes all the way over here, what's the y value going to do? Well, it's going to be all the way up here. It's going to go up this way. So as P goes to infinity, PD goes to infinity. As P goes to negative infinity, so all this way, then PD is going to also go to positive infinity. Okay?
How is it positive?
Because it's up. It's going up. Okay? You could argue, though, because P can never be negative, it's not going to go much higher than 40. Right? Okay? But typically, when you describe n behaviors, you describe to infinity. Okay? What's happening at the end of the graph? It's going up to infinity. Okay? Here, because we have absolute value, we wouldn't go past there. Okay? All right, so I'm going to go skip to the summary here, and then I want to take up a couple questions from the homework. And the reason why is because I actually feel that this was not a very well-structured lesson in terms of what's expected for you from the homework. Okay, so I want to explain some of the homework questions as well. So let's just go through the summary. F at x is the absolute value of x. On a number line, this function describes the distance f at x of any number x from the origin. So that's a little bit confusing. Okay, we got to think about this for a second. On a number line, this function describes the distance f at x. So f at x is the distance from 0, from the origin. Okay? So when you have a function that's an absolute value of x, that function value is the distance from 0. So of course that's going to be 3. The distance from 0 is 3. Okay? And we use distance from 0 because distance can go either direction, either positive or negative. Okay, so that's what they're trying to tell you there. For the function f at x equals the absolute value of x, there's 1, 0 located at the origin, okay, which is right here. The graph is comprised of two linear functions as defined as follows. So f at x equals x, which is this line, and f at x equals negative x, which is this line. Okay? So traditionally, what would happen with f at x equals x, if we were accepting negative values, we would have this line continue. Because we're making all negative values positive, it mirrors into the second quadrant. Okay? So that's why we get this V happening. And that's why we had a V for the blood pressure graph, because there can be no negative values. Any questions there? Okay, the graph's symmetric about the y-axis. We can see that as x approaches large positive numbers, y approaches large positive numbers. As x approaches large negative numbers, y approaches large positive numbers. Okay, we just talked about that. The absolute value has a domain of xer, so we cover all the values of x, and a range where y is greater than 0, so we don't have any negative values of y. Every input in an absolute value returns an output that is non-negative. We talked about that at the very beginning. All right, we're going to look at the homework question now. I just want to get you guys started. The homework is 1 to 8. Okay, but it's quite a bit different. It's quite a bit different from the lesson, and I'm going to show you. Okay, first one, arrange these values in order from least to greatest. Very, very simple. Nicholas, how would you do this one? Just do it in your head.
Well, negative 5 will go first, negative 50, 12, negative 15, 20, and negative 25.
Right. Okay, that's very, very easy. Any negative number is just going to become positive, and you're going to list them from lowest to greatest. Okay? Any questions for number 1? Simple. Evaluate. Number 2, also very simple. No issues with that. You guys should have no problem with that. Any negative value, you would do the operations, treat the absolute value brackets like regular brackets. So you conduct the operation inside them and then absolute value. Okay? Don't take the absolute value of negative 5 now until you've combined it with the negative 13. Okay? I think that's pretty easy. Number 3, express using absolute value notation. All right, so this one's a little different here. We need to express this as a function of an absolute value. So I'm going to write it here, 3a. It's less than negative 3, greater than 3. Sorry. Hold on. Let me just see how they write this. I don't have it. Yeah, do you have it?
Yeah.
I just want to get the same notation that they have. 3a. Yeah.
It's, the absolute value of x is greater than 3.
Okay, so we got to talk about that because you haven't seen anything like this in the lesson. So it says express using absolute value notation. So x is less than negative 3 or x is greater than 3. Okay, so we have to think of that as the absolute value of x has to be greater than negative 3. Okay, because if x is less than negative 3 here. So if we look at a second example, b, well, let's look at b. We're going to have x is going to be less than, the absolute value of x is going to be less than and equal to 8. Okay? Because between negative 8, so this is a function that represents all the values between negative 8 and 8. Okay, so negative 6 is in this function, negative 5. We need to express that as an absolute value term. Okay, so if we put in any value for x here, that's say negative 7, negative 6, negative 5, this equation is going to be true. Okay, it's a little bit difficult to explain. Let me go on, and then we'll come back. Okay, let's go on to number 4, because I looked at this and it is quite confusing, the way they word it and the way it's written. So graph on a number line. So this might help. So we graph 4A. we have a number line. Okay, so if we want to graph the absolute value of x is less than 8, okay, that means any value that we choose for x has to be less than 8 in order for this to be true, okay? So we're going to go less than 8, all of these values. So if I choose 7, this equation will be true. If I choose 5, this equation is true, correct? Okay? If I choose 9, this equation is not true, okay? That's why my number line doesn't go past 8. Does that make sense? But now, sorry, as I get to negative numbers, if I choose -1, this is still true, because it's going to be the absolute value of -1, which is 1, which is less than 8. So I can choose negative numbers all the way up to -8. Do you guys understand that? Because any of these, yep.
But it says less than 8. It doesn't say less than or equal to 8.
That's why I have open circles here.
Oh, okay.
Okay? The open circles represent not including that number. Okay? Open circles.
Not including 8?
Yes. Okay? Closed circles means including, and we'll show that on the next one. So that's 4A, here's 4B.
So technically, negative 64 is not less than 8. It wouldn't fit in the equation.
Say that again? Negative.
Let's say we get, let's say -9, it wouldn't work.
Right, exactly.
Even though -9 regularly is less than
Yes, because you absolute value of -9, which is +9. You're right. So our number line, we can't show -9 because we're going to take the absolute value of that. Let's look at 4B. So we have the absolute value of x is greater than and equal to 16. It wants us to put that on a number line. So I'm just going to say this is 16 and this is 16 here. Okay? So on this number line, I have to color in all the values that satisfy this equation. Okay? The positive side is easy because values that are greater than and equal to 16 are going to be 16 and up. Okay? So here's my number line. I'm including all numbers 16, 17, 18, and up. All those values will satisfy this equation. Agreed?
Yeah.
The trickier side is the negative side. If I just put in -15 here, it's going to get absolute value, and then it's actually going to be 15 is greater than and equal to 16, which is not right. So I can't put in 15. If I put in 16 or greater, sorry, -16 or less, I should say, it does satisfy this equation. Okay, if I put in -18 for x, which is over here, it's going to be greater than 16 once I take the absolute value. Okay?
Just so you can go beyond negative.
I can. -19, -300, yeah. They're all going to be greater. Okay, so see how it's a little bit confusing, right?
So you're trying to make the statement true.
Yes, exactly. On the number line. You're trying to represent the statement on the number line. So last one, I'll do D, 4D. The absolute value of x is greater than -7. Okay, so there's 0, there's 7, there's -7. Okay, so we'll do the positive side first. X has to be greater than -7. So there's -7. I'm going to do an open circle because it's not equal to, and it has to be greater than -7. And now, the negative side, it's going to be the same thing. So that's what I'm left with. Okay, so now one way to test it is just plug in numbers. If I plug in 0 for this, is 0 greater than -7? Yes, it is. If I plug in -1, which is here, right? -1, it's in my solid line. -1 absolute value is +1 is greater than -7, so that works. Okay, if I plug in -8, -8 does work, so this is wrong. Yeah. Right. So this was a bit of a trick question, right? All absolute value of any number is going to be positive. So in actual reality, this number line looks like this. Yeah. So my mistake. Any number works there. Okay? The back's wrong?
Yeah, it says -7, and it points to the left to infinity, and from 7 to the right to infinity.
So that's wrong. Yeah. That's the way I had it, right?
Yeah.
But that's wrong. Okay? The right answer is that, yeah, any number we plug in for x is going to be satisfy this equation.
Shouldn't you still have the open circles?
No.
Because does it say equal to? It's only greater.
Oh, yeah, I think you're right. Yeah, you're right.
So you have the circles.
You're right. Very good point, Marco. Thank you. Yeah, you have to have open circles on the 7s because they're not it's not equal to 7. If we plug in +7 here, the absolute value of no, sorry. It would still be right. Yeah.
Everything's
Yeah, because if you put in -7, it's going to be +7.
But that's not greater than oh
Yeah,
yeah.
it is. Yeah. Yeah, so. See, it's confusing though. This is a, early section of the chapter. It really stands out. You don't really use this moving forward, but it will be on your chapter 1 quiz. It is a little bit confusing. All right, let's move on. Graph 6, graph f at x, x minus 8. We talked about this right at the beginning of the lesson. There is no difference, okay? You'll find that when you graph it.
So how would you do C though?
C?
Yeah.
Okay. 4C. Absolute value of x is less than and equal to -4. Here's 4. Here's -4. So the value is less than and equal to -4. So if we plug in 0, it's going to not satisfy this.
It's a trick question.
It's another trick question.
Yeah, it can't be. It's
Yeah.
impossible
Because a positive value, this is positive. It can't be less. Can't be less than negative.
So that's just the extra result.
Yeah, that's another trick question there. Yeah. That makes sense, though, right? If we take an absolute value of any number, it's going to be positive, which could never be less than a negative number, right? Okay.
Did you say trick question?
You wouldn't. You would just write this: positive number can't be less than a negative number. So you could draw a blank number line. Okay, there's no value of x that we can put in that will make this equation true.
Could we put in
Okay, let's just go back to 3 because it might make a little more sense. All right. So if we look at 3, it says express using the absolute value notation. So let's say 3b. So if you think about this on a number line, let's do that right now. So here's 8, here's -8. Okay, we include 8, so x is all the values between here. Okay, including 8 and -8. So there's the number line representation of this. Now I want to show the absolute value notation. So I want to say the absolute value of x is going to be what? Does that make sense? Because now if we plug in -7, which is over here, it's going to be +7 is less than and equal to 8. If we plug in +5, it's going to be less than 8.
I'm doing it.
It should be still.